program is about measuring pH. pH? But what is pH? It's an abbreviation for the potential of hydrogen, which means that pH is a measure of whether a substance is acidic or basic. That's the acidity or alkalinity. Water, pure water, is neutral. It has a pH of 7.0 at 25 degrees Celsius. Acidic substances have pH values lower than 7. Basic substances have pH values of greater than 7. How is pH measured? It's worth remembering here that the availability of precision instrumentation should not necessarily dictate its use. There is a time and place for all techniques, and we should never discount rough and ready ways of doing things, which certainly applies to pH and the two ways of measuring it. For example, when we need only a very rough idea of pH, for instance, is the solution acidic or basic, a quick estimate can be obtained using indicators, or more likely, indicator papers. pH indicators are chemicals which change colour according to the pH they find themselves in. Cost usually equates to precision. A typical pH meter consists of a measuring probe connected to an electronic meter that measures and displays, and sometimes even prints out the measured pH value. Most modern probes are of a type called combination electrodes and can be quite complicated. Basically, the probe consists of two concentric tubes, the inner tube made from glass, the outer one made either of glass or plastic. An iron-sensitive could hardly be more simple. First, rinse the probe with distilled or deionized water to remove any traces of previous contact materials. Second, blot it dry with a clean tissue. Third, rinse again. And fourth, immerse it straight into the solution you want to measure. Glass electrode is not allowed to dry out. In most pharmaceutical laboratories, electrodes are stored in distilled water or deionized water, but for precision work, it is probably best to store the electrode in 0.1 molar hydrochloric acid or 0.1 molar sulfuric acid. Regardless of which, it is worth cleaning the probe by immersing it in 0.1 molar hydrochloric acid. If it is needed, this is a true calibration and is done against two standard buffers. For general purposes, pH 4 and pH 10. These buffers are available with certificates of conformance from all reputable laboratory supply houses. A typical pH meter has one calibration control to set the meter reading equal to the value of the first standard buffer, and a second slope control, which is used to adjust the meter reading to the value of the second buffer. The voltage arising from pH